Hey, what's up? I'm here to do another, lecture from aldehyde ketones and carboxylic acid. And what this topic is, this is a one again very important topic. What you call it, aldol, reaction and cross aldol. So, in case you are aware, previously I've done that aldol condensation reaction and all its, mechanism and how you can find out which chemical compound can undergo, aldol condensation reaction. So this time it's going to be, how you can perform a cross-aldol reaction, right? While you do it theoretically, right? So there are going to be some mechanism, there are going to be some reaction here. But before I come to the writing part, let me tell you what this is. Cross-aldol reaction actually involves reaction between two different aldehyde, or reaction between two ketones, or reaction between one aldehyde and one ketone. But in all the three cases I made you go, there must be alpha hydrogen, right? So alpha hydrogen is very, very important for a compound in order to go cross-aldol reaction or aldol reaction, right? So in case you are missing what this alpha hydrogen is, you can go and check out the previous two lecture, and then you will be very much sure what this alpha hydrogen is and what is the contribution here. So let me come to the writing part and tell you what this is. So like I said, cross-aldol reaction, pay attention here. Cross-aldol, reaction can take place between two different aldehyde with alpha hydrogen. It may be two different ketones with alpha hydrogen, or it may be an aldehyde and a ketone with alpha hydrogen. So a cross-aldol reaction can take place in these three conditions actually. Let me repeat back. There may be two aldehyde, this should be different. There may be two ketones, they must be different. And there may be one aldehyde and one ketone, and there's nothing to mention like different because they are already different. But very important condition is they should have an alpha hydrogen, right? So these are the three conditions. So let me take you through some examples. I am taking a reaction between ethanol CH3 CHO and a reaction between propanol. So CH3 CH2 and CHO, right? This is your ethanol and there you have your propanol. Let me write the name, propanol, and there you have your ethanol. Now what happened here? They are treated with dilute NaOH. Now it gives actually four products, ethanol plus ethanol. The second one is going to be propanol plus propanol plus propanol. The third is going to be ethanol plus propanol, and the fourth is going to be propanol plus ethanol. So this is how you will get four different products, and I'll show you how these four products will be coming up, right? So in case you needed to make sure how many products are going to be, there will be four products. Why? Let me tell you. In a mixture of ethanol propanol, it is possible that two ethanol can react together. It is also possible that two propanols can react together. It is possible that ethanol react with propanol, and it is also possible that propanol react with the ethanol. The third one seems to be similar, but there is a difference here, difference in the product coming out to be. So let me take you through the reaction part here. So what the reaction part is ethanol ethanol so dilute NaOH. What will happen? This OH negative. So the first condition is that when an ethanol is treated with dilute NaOH, what happens? This bond undergo cleavage. And if this bond undergo cleavage, the OH comes out with H and it forms water. And other product you get is a carbon ion with an aldehyde group. Then, you treat this product with the second molecule of ethanol. Second molecule of ethanol. So what happened? This bond undergo cleavage. And if this bond undergo cleavage, you have a partial, positive charge here and a partial negative charge here. So this carbon attach itself to this carbon. So you get a product, CH3. This one. You have a C single bond O and you have an H here. You have an H here and that carbon is coming up here with C double bond O H. In the next step, what happened? It reacts with water. It reacts with water which produce hydrogen ion. This hydrogen ion, will shift towards the oxygen and then it will form a hydroxyaldehyde. Then it will form, there is 1, 2, 3, 4 here. 4 here. Right? You have H2 here. And then you have, H here. H here. And finally you have CH3 here. And in the last step, what happened? This undergo condensation. Undergo condensation. During the condensation, what happened? The alpha hydrogen. This is your alpha and this is your beta. So from there, OH will be coming out and from here, H will be coming out. Right? So this will produce water, which will evaporate, and there a double bond will be restored. So CH3, CH, double bond, CH, and finally you have CHO. So what this is called? Butenol. Butenol. So this is how you get your first. This is the, ethanol with ethanol. Ethanol plus ethanol. Right? So this is the first product. This is the first product. Similarly, the other product going to be, let me take you through the same part. So I have to remove this off. Now I am taking propanol with propanol. Taking propanol with propanol. This is your propanol. So when a propanol react with NaOH, again dilute. So what happened? And hydrogen from here, breaks out and it's combined with OH negative. So it produces H2O and this produces secondary carbon ion. This produces a secondary carbon ion. Right? And in the next step, this one react with another propanol. So what happened? This bond undergo cleavage, you get a negative here and you get a polar positive. So what will happen? This will shift here. And in that case, 1, 2, 3, right? Okay, so there you have the middle one. This is the, so what I'm doing, C double bond O, this one, then you have C with another C over here, CH3, and then you have this carbon, right, with a single bond, oxygen, and you have 2 more carbon. I'm not placing the hydrogen because you can understand that. So this is what happened. Then you have a negative charge here. In the next step, what happened? This react with water. Water which donates a proton. So this proton shift over here, and this become, hydroxy again. So you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first one has an aldehyde, and the third one has an hydroxy now, and rest is okay. So the second one also is having a methyl group here. Finally, condensation takes place. Finally, condensation. What condensation mean? Heating it. So when you heat, what happens? There you have your hydrogen, there you have. So that these two are removed. So this becomes a double bond here. So C double bond O H with another C, third one, fourth one, fifth one. But you have between second and third a double bond. And then you also have a methyl group here. So this is the second product. This is the second product. Second one. And what, this is coming from propanol and propanol. Propanol and propanol. What this name is going to be? This is going to be 2-methyl, 1, 2, 3, 4, 5, pent, 2-enol. So this is how you get the second product. Now let me do the third one, right? I know this is going to be really lengthy, but I want to make sure you understand each and every part in a very, simple way. So that's why I'm doing, all the reaction possible. So this is your second product, and what the second product is? 2-methyl pent 2-enol, right? So the third one, where I'll be reacting the propanol with the ethanol. So after this step, this become a carbon ion. This become a carbon ion, right? And you have a aldehyde here. So when this aldehyde react with ethanol, what happened? The bond undergo cleavage. This become negative and this become positive. So this carbon again join itself with the carbon. So this way you get, 1, 2, 3. 1, 2, 3, and you have a carbon right here, CH3, this one, and this carbon will bond to the, single bond O and another carbon, right? So within this going to be negative. Then in the next step, what will happen? This will react with the water molecule. So water will produce a hydrogen ion. This hydrogen ion will go over here. So this become a, a product like double bond O. That's 1, 2, 3, 4. 1, 2, 3, 4 with a methyl group right here. Methyl group right here, and this will be a hydroxy group now. This will be a hydroxy group now. Check this out here, right? And in the last step, what will happen? This will undergo condensation. Undergo condensation. So during the condensation, what will happen? Hydrogen from here and hydroxide from here will come out. So this will form 1, 2, there will be double bond carbon, single bond carbon, but there is a methyl here. So this is your third product coming up, and what this third product is, let me write. This is, third one from propanol plus ethanol. Propanol plus ethanol. Now I'm sure I've done 3 of the mechanism, so you can do the 4th one as well. So what I'm going to do, is to write all the 4 products together, and you will get the exact reaction here, right? So what we had a, ethanol CH3 CHO was reacting with the propanol CH3 CH2 and CHO, right? They were treated with dilute NaOH, but they were also heated. And after that you have you have 4 products coming up, and that's the first one was ethanol plus ethanol will be producing butanol. So this is going to be, let me write straight. This is your butanol. Right? Another product is going to be, propanol plus propanol, where this is going to be 1, 2, 3, 4, 5, and it's going to be, so this is right here, 2-methyl pent 2-enol. Now, so this product is coming from ethanol plus ethanol, while this is coming from propanol plus propanol. Similarly, this is your 2-methyl butanol, and this is coming from, propanol plus ethanol. Similarly, the fourth one is going to be pent 2-enol. So this is your pent 2-enol, and this is coming from ethanol plus propanol. So this is how the overall reaction looks like, which was really complicated and a bit lengthier. But if this doesn't go smooth in the first watch, you have to go back and repeat, because something when you have really hard, you have to do it again and again. So the practice you do, that will make you perfect, right? So I want to say, watch it and let me know how this has been to you.